A cosmic enigma defies odds and logic. China's Mars orbiter captures a rare glimpse of 3I-ATLAS. While NASA remains silent, China has just changed everything. Between October 1st and 4th, 2025, China's Tianwen-1 probe orbiting Mars captured images of 3I-ATLAS, the interstellar visitor racing through our solar system. One image taken on October 3rd from nearly 29 million kilometers away stunned scientists. It revealed not just a glowing tail, but a sprawling coma thousands of kilometers wide. What Tian saw wasn't just another comet. It was a question written across the universe, and no one has an answer yet. The first glimpse, how Tianwen-1 caught the interstellar wanderer. When the China National Space Administration announced the detection, it sent ripples through the global astronomy community. Their Tianwen-1 probe, quietly orbiting Mars since 2021, wasn't built for deep space comet chasing. It was a planetary surveyor designed to study Martian dunes and polar ice. Yet, in early October 2025, it turned its high-risk high-resolution camera away from the red planet and toward an unknown traveler. 3I-ATLAS, the third confirmed interstellar object ever detected. Capturing it wasn't simple. 3I-ATLAS was dim, fast, and unpredictable. The probe's instruments were calibrated for bright surfaces, not faint light drifting against a star-filled backdrop. Every exposure had to be timed precisely, and engineers spent nights recalculating trajectories, so the camera could track an object moving tens of kilometers. For 4 days between October 1st and 4th, 2025, Tianwen-1 hunted the wanderer across the Martian sky. Then on October 3rd, success came from roughly 28.96 million kilometers away. HiRIC captured the clearest view ever of 3I-ATLAS. The image showed a compact radiant nucleus surrounded by a coma stretching several thousand kilometers across. Even through the static and cosmic haze, something about the symmetry looked deliberate, almost sculpted. Scientists in Beijing called it a once-in-a-lifetime frame. To them, it wasn't just a comet. It was a living fragment of another solar system, frozen in motion, drifting past Mars like a messenger from time itself. The data stunned mission planners. No other spacecraft had ever photographed an interstellar object so closely from another planet's orbit. China had done what no other nation, not even NASA, had achieved. And the fact that these images arrived while NASA's own high-resolution files remained sealed only deepened the mystery. The camera that shouldn't have worked. HiRIC's impossible shot. HiRIC, short for high-resolution imaging camera, was never meant to see something like 3I-ATLAS. It was engineered to photograph bright Martian terrain, mapping craters and dust storms, not to chase a fast-moving dim interstellar object across the void. Yet somehow, in the first week of October 2025, it pulled off what astronomers now call an impossible shot. The challenge was physics itself. 3I-ATLAS was racing past Mars at speeds exceeding 68 kilometers per second. A blur of frozen gas and rock from Tianwen-1's orbit. Even the slightest timing error could have left the comet invisible. A streak of nothing across blackness. The camera team knew this. They calculated and recalculated exposure time, adjusting for orbital drift, solar glare, and the comet's unpredictable brightness. HiRIC was pushed to its absolute limits. When the images returned, they were astonishing. Against a backdrop of distant stars, a faint glowing figure appeared, sharp enough to reveal both the solid nucleus and the vast hazy coma that surrounded it. The brightness gradient suggested the object was active, venting material in real time as it passed through the solar wind. What shouldn't have been possible was now undeniable. China's Mars probe had successfully captured the first clear interstellar image from another planet's orbit. Behind the scenes, engineers admitted something strange. The exposure pattern had to be shifted mid-capture because the object's movement wasn't matching the predicted paths. 3I-ATLAS seemed to be drifting slightly off course, as though propelled by something beyond solar radiation or gas jets. It wasn't a huge change, only a fraction of a degree, but enough to raise questions about what was really guiding it. The moving shadow, China's GIF that shocked the world. A single still image would have been historic enough, but China didn't stop there. A few days after the Tianwen-1 announcement, the China National Space Administration, CNSA, released something that stunned the world. An animated gift made from multiple high frames. It showed 3I-ATLAS moving slowly across a field of background stars. A faint blue-white light shifting almost imperceptibly with each frame. It was short, grainy, and silent. Yet, it carried more weight than any press release NASA had issued in months. That simple animation, a glowing dot gliding through the darkness, confirmed one thing. 3I-ATLAS was alive with motion, not a frozen relic drifting passively through space. The images revealed how the comet's coma shimmered as it rotated, its brightness fluctuating in subtle patterns. Astronomers analyzing the sequence noticed that the tail appeared to bend and pulse as if reacting to invisible forces. Some attributed this to solar wind interference. Others saw something more deliberate, a rhythm too structured to be random. Across social media, the clip went viral within hours. Space enthusiasts called it the blink of another world. Scientists marveled that TN1 had captured what even Hubble and Webb hadn't yet shown, the unmistakable living motion of an interstellar traveler. And while the world debated what it meant, NASA stayed quiet. Their high-rise data collected at nearly the same time still hadn't been released. That silence gave the gift an eerie power. For the first time, the public was seeing something humanity couldn't fully explain. An object from another star system caught mid-flight, defying predictions. The faint flicker of 3I-ATLAS wasn't just light. It was information whispering across the void, teasing a mystery no one was ready to solve. What China had released wasn't just an image. It was a message. And it made the rest of the world realize they might be looking at something far beyond science as we know it. The strange glow inside the coma of 3I-ATLAS. When Chinese scientists enhanced the images from Tianwen-1, they found something they hadn't expected. Around the solid core of 3I-ATLAS was a massive shimmering cloud. The coma stretching thousands of kilometers across, but this wasn't the kind of glow astronomers were used to. It didn't diffuse gently into space the way a normal comet's tail does. It pulsed as if lit from within. Every frame showed tiny fluctuations in brightness, too regular to be camera noise, too organized to dismiss as a coincidence. Normally, a comet's coma glows because sunlight heats its icy surface, releasing water vapor and dust. Yet, the analysis of Tianwen-1's data showed that 3I-ATLAS's coma contained far less water than expected. The light signatures pointed to carbon dioxide dominating the mix with trace elements of nickel and unknown metallic compounds. Those readings didn't fit any model of a natural comet. It was as if the object's chemistry was fine-tuned for resilience, built to survive radiation, heat, and pressure that would destroy ordinary material. The glow also behaved strangely when compared to known reflections. In one segment of the sequence, the inner halo brightened sharply, then faded again in perfect cycles, almost like a heartbeat. Some speculated this could be caused by rotation, but the rhythm didn't match the object's predicted spin rate. That meant the light was likely coming from localized emissions, not just reflected sunlight. NASA, still holding on to its unreleased high-rise images, offered no comment. But everyone knew that if those sharper US images existed, they could confirm or deny what Tianwen-1 had seen. Until then, the only clear evidence came from China. And that eerie steady light coming from an object not meant to glow that way kept the mystery alive. The impossible distance. How China's probe captured it from 29 million kilometers away. At first, the numbers didn't seem real. The TN1 probe orbiting Mars had captured its now famous 3I-ATLAS images from nearly 28.96 million kilometers away. A distance so vast it defied logic for a camera not designed for deep space photography. To put that into perspective, that's about 75 times the distance between Earth and the Moon. At that range, even a tiny miscalculation in focus or trajectory could mean missing the target entirely. The high-eric camera aboard Tianwen-1 wasn't meant for this kind of work. It was engineered for bright Martian terrain, rocks, dunes, and canyons, not for faint cosmic specks racing through the blackness. Yet, in early October 2025, the Chinese team repurposed it for one of the boldest imaging attempts in space exploration history. Using a series of manual corrections and long exposure sequences, they managed to lock onto 3I-ATLAS as it streaked through the solar system, traveling at tens of kilometers. What made it even more remarkable was the clarity of the data. Despite the enormous distance, the images showed not only the nucleus, but also the detailed coma structure. Proof that the probe stabilization and tracking system was operating with almost supernatural precision. Each pixel of that image represented millions of kilometers of space, and yet the details aligned perfectly. But what truly intrigued scientists was why Tianwen-1's team had aimed at 3I-ATLAS in the first place. China's space agency had quietly tracked it for months, long before it became public news. That meant they knew exactly when and where to look. Whether it was foresight, coincidence, or inside knowledge, one fact became clear. The clearest look humanity had ever gotten at an interstellar visitor came not from NASA, but from Beijing. And with that, the balance of discovery and secrecy had shifted. The silence from NASA. Why the US hasn't released its own images. As China's Xiaonan-1 images spread across the internet, excitement turned to frustration in the West. For weeks, people kept asking the same question. Where are NASA's images? After all, the United States had its own spacecraft, the Mars Reconnaissance Orbiter, equipped with the HiRISE camera, capable of 3 times the resolution of TN-11's HiRIC. It had observed 3I-ATLAS around the same time. Yet, not a single photo had been released. Officially, NASA said the delay was due to the federal government shutdown that began just days before the comet's closest pass to Mars. According to the agency, non-essential operations, including data releases, were temporarily suspended. But that explanation didn't sit well with scientists or the public. A government shutdown could pause press briefings, yes, but not the transmission of raw space data. The Mars Reconnaissance Orbiter still had power, bandwidth, and instructions ready to send back information. As days turned to weeks, the silence grew suspicious. China had managed to capture, process, and publish its images within days, while the US, with better instruments and a larger team, remained quiet. Even members of Congress began to take notice. On October 31, 2025, Representative Anna Paulina Luna sent a formal letter to NASA's acting administrator demanding the immediate release of the 3I-ATLAS data and images. Her message was direct. The public had a right to see what their tax-funded satellites had captured. The longer the delay continued, the more China's achievement dominated headline. For the first time, it wasn't NASA leading a major space discovery. It was China shaping the narrative of an interstellar mystery. And that silence, intentional or not, only deepened the sense that something about 3I-ATLAS was far stranger than anyone was willing to admit. The political shockwave. Congress steps in. By early November 2025, the situation had escalated far beyond astronomy. What began as a scientific delay had now become like and subscribe channel.